All right, aviation fans, get ready to dive deep because today we're all about PBN.
PBN?
Yeah, performance-based navigation,
Yes,
and why it's the hot topic for instrument flying in Europe,
Especially.
especially for UGA pilots out there. We're going beyond the jargon
Right.
and really getting into the practical stuff, using excerpts from the PBN manual as our guide. Think of this as your shortcut to understanding how PBN is changing the game.
Yeah, what's exciting is how PBN,
Okay.
especially when paired with GNSS,
Yeah.
it's like trading your old road atlas for a cutting-edge GPS.
Mm-hmm.
It's about precision, flexibility,
Right.
and opening up a world of possibilities
Really
in the air.
So less following those rigid ground-based signals and more freedom to fly efficient routes. Okay, let's break this down.
Okay.
What exactly is PBN,
Yeah.
and why should a pilot care?
Imagine this. You're planning a flight, and instead of being limited to fixed airways,
Right.
like highways,
Mm-hmm.
you could design a route tailored to your aircraft and the weather.
Oh, wow.
That's what PBN allows. It's a framework for achieving very specific navigation performance.
It's like having the power to choose the scenic route, but with the reassurance that you're still on track
Yes.
and meeting those strict safety standards.
Exactly.
Yeah.
And here's where it gets even cooler.
Okay.
PBN has two main players, RNAV and RNP.
Okay.
Think of RNAV as hitting those marks on your GPS.
Mm,
You're navigating accurately.
right.
RNP steps it up a notch.
Okay.
It's like having your... making sure you're not just accurate,
Right.
but consistently within those tight tolerances.
RNP.
Yes.
It's like having that extra layer of confidence, especially when you're flying in challenging conditions.
You've got it.
Okay.
And while this manual focuses on European regulations and using GNSS,
Right.
which is a big part of PBN for GA in Europe,
Mm-hmm.
these concepts have implications for aviation globally.
It's like learning the rules of the road,
Yes?
even if you're driving in a specific country. Those fundamental principles apply everywhere.
Precisely.
Yeah.
Now, since this deep dive is all about practicality,
Okay.
you know you're busy.
Right.
Let's zero in on what's most relevant for you as GA pilots here in Europe.
Okay.
This manual hones in on single pilot operations, using GNSS for departures,
Right.
arrivals,
Yeah.
and those all-important approaches.
No time wasted.
No.
We're going straight to where the rubber meets the runway. But before we get there,
Yes.
let's make sure we're all on the same page about GNSS.
Okay.
Sometimes I get it confused with GPS.
It's an easy mix-up.
Yeah.
Think of GPS like Kleenex.
Okay.
It's a specific brand name.
Right.
In this case, the U.S. Satellite Navigation System.
Nice.
GNSS is the broader category, like tissues,
Huh?
encompassing GPS, GLONASS, Galileo, you name it.
So GNSS is the big umbrella,
Yes,
and GPS is just one of the players under it.
you've got it.
Okay, cool.
Now imagine GNSS as having three essential parts.
Okay.
The space segment, those satellites orbiting above us.
Uh-huh.
The control segment, ground stations keeping tabs on everything.
Okay.
And the user segment,
Right.
which is your receiver in the cockpit.
It's like a well-choreographed dance with all these different elements working together seamlessly to pinpoint your location.
Exactly.
Yeah.
But just like any system,
Right.
GNSS isn't immune to errors.
Sure.
Think about it. Atmospheric conditions,
Mm-hmm.
satellite positions,
Yeah.
even your aircraft's maneuvers
Right.
can throw things off.
Sure.
That's where augmentation systems like EGNOS come in.
EGNOS. It sounds like a VIP bodyguard for your GNSS.
That's a great way to put it.
Yeah.
EGNOS, specifically in Europe,
Right.
enhances the accuracy and reliability of your GNSS signal.
Okay.
It's like having an extra layer of assurance, especially when you're relying on it for approaches.
I like the sound of that.
Yeah,
But what about those times when EGNOS might not be available?
good question.
Yeah.
That's where RAIM,
Oh.
or Receiver Autonomous Integrity Monitoring,
Mm-hmm.
steps in. Think of RAIM as your backup system.
Gotcha.
It constantly checks the integrity of the satellite signals,
Right.
making sure you're getting reliable information,
Okay.
even without IGNOS.
So EGNOS is like that trusty co-pilot, always double-checking.
Yes,
And RAIM is your backup system in case things get hairy.
exactly.
Okay, now let's get to the heart of PBN procedures, those path terminators.
Path terminators might sound intimidating,
Okay.
but they're really just the building blocks of how PBN procedures are designed and coded.
Right.
Imagine you're programming your GPS. These are the instructions telling your aircraft how to fly from point A to point B
Right.
with pinpoint accuracy.
So it's like a secret language that your GPS understands.
Precisely.
Yeah.
And visualizing this is key.
Okay.
Think about flyby versus fly over waypoints.
Okay.
Imagine those dots on your GPS screen with flyby. You're smoothly transitioning from one segment to the next.
Right.
Like following a gentle curve.
Right.
Flyover is more abrupt.
No.
You're aiming directly for the waypoint.
Right. Which can be less accurate.
So for RNAV, which prioritizes accuracy, flyby is the preferred method because it creates a more predictable path.
You got it.
Yeah.
And this is particularly important when we're talking about arrivals and approaches those critical forces of getting you safely on the ground.
All right, let's talk about stars and approaches.
Imagine stars, or standard terminal arrival routes,
Okay.
as those highways in the sky
Right.
guiding you toward your destination airport.
Mm-hmm.
Approaches are like those off-ramps leading you to a specific runway.
Makes sense. So how do these RNAV procedures, those flexible GPS-guided routes, fit into this picture?
Here's where it gets interesting.
Okay.
RNAV procedures often use the existing conventional procedures as their foundation.
Okay.
It's like taking that old highway and giving it a high-tech upgrade.
Right.
You're essentially using the same route,
Okay.
but with the added precision and flexibility of GNSS.
So it's a win-win. You're leveraging existing infrastructure,
Yes,
but with the benefits of modern technology.
exactly.
Now, when it comes to approaches specifically,
Okay.
there's an important distinction between database overlay approaches
Okay.
and true RNP approaches.
Gotcha.
A database overlay approach is like using your GPS for most of your road trip,
Okay.
but then needing to rely on those old-fashioned road signs for the last bit.
Right.
You're primarily using GNSS,
Yeah.
but there might be points where you need to switch back to conventional aids.
It's like a hybrid approach.
Yes.
Using the best of both worlds.
Exactly.
So what about those true RNP approaches?
RNP approaches are the real deal.
Okay.
It's like having that super reliable,
Yeah.
state-of-the-art GPS that gets you right to your destination
Right.
with incredible accuracy.
Yeah.
You're relying solely on GNSS,
Right.
which means your equipment needs to meet stringent performance requirements.
It sounds like RNP is the gold standard for precision approaches.
It is.
Yeah.
And because it's so central to the future of PBN,
Right.
especially for GA operations, let's take a closer look at how they work in practice. When you visualize an RNP approach, think of those standardized Y, T, and trident shapes
Okay.
you see on approach plates.
Right.
They're like the blueprints for precision.
Ah, so it's not random. These shapes help pilots quickly grasp the approach layout at a glance.
Exactly.
Yeah.
It's all about clear,
Significant pressure.
consistent information in the cockpit.
Right.
And you'll often hear about radar vectors guiding pilots to specific points within these procedures.
Right.
Think of it as air traffic control giving you personalized directions
Okay.
to line you up perfectly for the approach,
Right.
like a choreographed dance in the sky.
So even with RNP, there's still that human element, that collaboration with ATC.
Absolutely.
Yeah.
But here's where things can get a little tricky for pilots, those naming conventions on charts versus what you see in your GPS database.
Yeah.
It's translating between languages.
Oh, I've totally been there. Trying to match up those cryptic codes can be confusing. So how do we avoid getting lost in translation?
Careful cross-checking is key.
Oh,
Make sure what's on your instruments matches those official charts.
right.
Now, speaking of those instruments, understanding minima lines is crucial for RNP approaches.
Right.
We're talking about LNAV, LNAVNAV, and LPV,
Okay.
each offering a different level of precision and capability.
Okay, so it's like choosing the right tool for the job,
Exactly.
depending on the weather and approach type.
Yes.
Let's break these down, starting with LNAV.
Think of LNAV,
Okay.
or lateral navigation, as your reliable but basic GPS.
Okay,
It keeps you on track horizontally,
right.
but you're responsible for nailing those altitudes based on the approach chart,
Okay.
just like following a map on a road trip.
No autopilot for vertical guidance there.
Right.
So you need to be comfortable with your instruments and those good old-fashioned calculations.
Precisely.
Yeah.
Now, imagine you've got a fancier GPS unit with extra features. That's where LNAV-NAV comes in.
Okay.
If you have an SBAS-capable receiver,
Uh-huh.
LNAV-VND adds that vertical guidance,
Okay.
like having a co-pilot calling out altitudes as you descend.
Ah, so it's like those highways with gentle slopes guiding you down.
Yes.
You're still in control,
You are.
but the system is lending a helping hand.
Exactly.
Yeah.
Now, picture this. You're landing in low visibility,
Okay.
maybe even some fog.
Right.
It can be nerve-wracking, right?
Oh, yeah.
That's where LPV
Okay.
or localizer performance with vertical guidance
Okay.
steps in.
LPV sounds like the superhero of approaches.
It's pretty close.
Okay.
LPV offers that super precise guidance, comparable to an ILS,
Wow.
getting you down to lower altitudes when those conditions get tough.
Okay.
But here's the catch.
Okay.
You need both SBAS and a capable receiver.
It's like having that top-of-the-line GPS with real-time traffic updates and lane guidance.
Yes.
The work.
Exactly.
Okay.
Now let's walk through what it actually looks like to fly an RNP approach from cockpit prep to touchdown.
Oh.
First things first. You've got your clearance, loaded the correct procedure,
Right.
double-checked it against your charts,
Hmm.
and you're keeping an eye out for any NOTAMs,
Right.
especially those concerning SBAS availability.
So preparation is key.
Yes,
Making sure your information is current and you're aware of any potential hiccups along the way.
absolutely.
Yeah.
As you're approaching the initial approach fix,
Okay.
that's your cue to double-check.
Yeah.
Does your position on the GPS match up with those charts?
Right.
It's all about maintaining that situational awareness.
Always good to confirm before committing fully to the approach.
You got it.
Yeah.
And remember,
Yeah.
throughout the approach,
Yeah.
you're laser-focused on those instruments.
Yeah.
Your CDI, altitude,
Right.
any warnings or alerts that pop up.
It's like having a mental checklist running, constantly scanning for any deviations.
Yes.
What happens if something seems off and you need to execute a missed approach?
That's where things get really interesting with RNP approaches.
Okay.
The missed approach procedure is a bit different from what you're used to with conventional approaches.
Different how? Give us the inside scoop.
First off,
Yeah.
that missed approach point,
Okay.
where you make the call to go around,
Great.
it's typically at the runway threshold
Okay.
with RNP.
Yeah.
You might have already climbed a fair bit before reaching it.
So it's not that last-minute decision right over the runway like with some traditional approaches.
Exactly.
Right.
And here's the key difference with RNP.
Okay.
You've got to manually tell your GPS to switch to the missed approach route.
Oh,
If you don't,
yeah.
it'll keep guiding you along that runway center line,
Right.
which you definitely don't want when you're trying to climb.
That's a crucial difference, almost like having to switch navigation modes on your GPS.
That's a great way to think about it.
Yeah.
And here's another pro tip.
Okay.
Some older RNP approaches might incorporate conventional aids like NDBs in their missed approach procedures.
Okay.
If your aircraft isn't equipped for that,
Right.
you've got to talk to ATC and request an alternative before you even begin the approach.
Okay, so communication is key.
Yes,
Always better to be prepared and have a plan B,
exactly.
especially when dealing with instrument procedures.
Yes.
Speaking of being prepared,
Right.
this manual stresses understanding what your specific equipment can handle.
It does.
It's not a one-size-fits-all situation, right?
Absolutely. There are different GNSS receivers out there,
Right.
and some are more capable than others.
Sure.
This manual does a great job of breaking it down.
Okay.
But let's simplify it for you.
Okay.
Think of it like this.
Yeah.
You've got your basic GPS unit,
Right.
and then you've got those high-end models with all the bells and whistles.
So what's the difference maker for pilots when it comes to these receiver types?
In the world of RNP approaches,
Yeah.
especially those slick ones with vertical guidance like LPV,
Right.
you need a receiver that can handle SBAS.
Okay.
We're talking about TSO C146 receivers. They're like the top-of-the-line GPS units that can utilize those accuracy boosting signals.
So if you want to unlock the full potential of RNP,
Yes.
you need the right gear.
You do.
But it's not just about the receiver itself, is it?
You're sharp. It's about the entire installation.
Okay.
And making sure it's all documented and approved
Right.
in your aircraft's paperwork.
Okay.
Think of it like this. You wouldn't want to show up to a Formula One race with a souped-up engine if the rest of your car wasn't built to handle it right.
That's a recipe for disaster. So proper installation and certification are crucial.
Absolutely.
Yeah.
Now imagine this.
Okay.
You've got the best GPS in the world,
Right.
but the maps it's using are outdated. You're going to run into trouble. Right. It's the same with your navigation database.
Okay.
Keeping that data fresh and accurate is essential.
Database management. It might sound a bit technical,
It is.
but it makes perfect sense.
That does.
It's the foundation for everything your GPS does.
Yep.
Like having the latest and greatest maps for your road trip.
Precisely.
Yeah.
And just like your phone reminds you to update your apps,
Right.
the aviation world has a system for updating this critical data, the AIRAC cycle.
Okay. AIRAC cycle. Tell me more.
Okay.
I'm always a little fuzzy on that one.
Think of AIRAC,
Okay.
which stands for Aeronautical Information Regulation and Control,
Right.
as a global syncing of watches.
Okay.
It's a standardized schedule for releasing changes to navigation data,
Right.
making sure everyone in the aviation world is working from the same playbook.
So no outdated maps leading us astray.
Exactly.
Yeah.
And these updates happen every 28 days.
Okay.
So staying current is key
Right.
to ensure top-notch data quality.
Yeah.
We have standards like RTCA DO200A and Euro CE ED76.
Right.
These are like the quality control experts in the navigation data world,
Right.
making sure everything is accurate and reliable.
It's like having that seal of approval,
Yes,
letting you know the information you're relying on has been rigorously vetted.
exactly.
Cool.
Now let's talk about how this data is actually coded.
Okay.
That's where ARA-NC 424 comes in.
ARA-NC 424 sounds like a secret code for pilots. What's the deal with that?
Think of it like this in the world of computers.
Mhm.
Everything needs a specific name or identifier
Right.
so that systems can talk to each other.
Right.
ARA-NC 424 is a way to standardize those names and codes for all things navigation,
Okay.
ensuring your GPS, charts, and ATC are all on the same page.
So it's like a universal language for aviation navigation.
Exactly.
Okay.
But sometimes those traditional names we use on charts don't quite translate into this digital language,
Right.
or they might not be unique enough.
So we need a workaround.
That's where computer navigation fixes, or CNFs, can come into play.
Okay.
These are like virtual waypoints created specifically for your GPS.
Okay.
They've got their own naming conventions that play nicely with ARA-NC 424,
Gotcha.
making sure every point in that database has a unique identifier.
So it's like adding those extra landmarks to your GPS map to ensure super accurate guidance.
Exactly.
Cool.
Now, I know this might seem like a lot of technical jargon,
Yeah.
but understanding these behind-the-scenes details is crucial for you as pilots.
Right.
It all boils down to safety and efficiency in the air.
It's like anything else. The more you understand how things work,
Exactly.
the better equipped you are to use them effectively and safely.
Yes.
So let's shift gears a bit and talk about the ESA learning objectives this manual covers.
Okay.
It's like the cheat sheet for acing that PBN exam, right?
You could say that.
Yeah.
This manual does a fantastic job of hitting all those key knowledge points
Okay.
that ESA wants you to know about PBN and GNSS.
Right.
And it doesn't just scratch the surface.
Yeah.
It gives you those real-world examples and dives deeper into the practical stuff.
It's not just about memorizing facts. It's
Abs-
about truly understanding the concepts and how to apply them in the cockpit.
Precisely.
Okay.
And it goes beyond those basic objectives, too. We're
Yep.
talking detailed examples of departures,
Right.
arrivals,
Yeah.
different types of approaches,
Right.
all those things you'll encounter in your flying.
It's like having a simulator session built right into the manual, helping you visualize how these procedures come to life.
Absolutely. Because at the end of the day,
Yeah.
knowledge is only powerful when you can put it into practice.
Right.
And that's where flight training comes in.
All right, let's talk training.
Okay.
Because it's one thing to read about PBN.
Yes.
It's another to actually fly it.
You got it. This manual outlines a comprehensive training course,
Okay.
like having a personalized roadmap for developing your PBN skills.
Right.
It breaks down those key objectives
Mm-hmm.
and recommends a structured approach to building proficiency.
It's like having a personal trainer for your instrument flying,
Yes,
guiding you through those exercises to build confidence and competence.
exactly. The syllabus covers everything,
Wow.
from general PBN theory
Okay.
to hands-on practice,
I know.
ensuring you understand not just the what,
Mhm.
but also the how.
Right.
We're talking various approaches,
Yes.
departures,
Yeah.
arrivals,
Uh-huh.
manual flying,
Right.
autopilot, use the works.
So it's a well-rounded approach to training,
It is.
covering all the bases.
Yes.
Yeah.
And here's what I really appreciate.
Okay.
It emphasizes contingency planning.
Okay.
What happens if your GNSS goes down?
Right.
How do you transition to those backup procedures?
Yeah.
These are essential skills for any instrument pilot.
Right.
And this manual doesn't shy away from them.
It's like having a backup plan for your backup plan.
Exactly.
Always be prepared.
Absolutely.
Yeah.
Always be thinking ahead.
Okay.
Now, this manual goes above and beyond,
Okay.
offering additional insights in the appendices.
Okay, cool.
We're talking a deep dive into how GPS actually works,
Okay.
like taking a peek under the hood.
I love that stuff.
Yeah.
I'm always curious about the inner workings of these systems.
It's fascinating. We're talking about satellite signals, ranging codes,
Right.
the navigation message, understanding how it all comes together
Yeah.
to pinpoint your location with incredible accuracy.
It's like discovering there's a whole secret world operating behind the scenes
Yes.
that we often take for granted.
Precisely.
Yeah.
And it gets even more interesting, different types of GPS signals.
Okay.
Civilian versus military application.
Right. Yeah.
GNSS augmentation systems like SBAS and ABS. It's all in there.
So it's like a crash course in GNSS technology.
Essentially.
Yeah.
It even breaks down RAIM, that crucial backup system we talked about earlier.
Right.
It explains how your receiver can independently verify the integrity of those satellite signals.
It's like having that built-in safety net giving you peace of mind when you're flying solely on GPS.
Exactly.
Yeah.
It also delves into the geoid,
Okay.
which sounds complicated, but is really just about how we measure altitude accurately using mean sea level.
So it's getting into the nitty-gritty of how those altitude readings on our instruments relate to the real world.
Exactly.
Yeah.
And it emphasizes the importance of the WGS-84 datum.
Okay, WGS-84 datum. You're going to have to break that one down for me.
Think of it as the common language that ensures your GPS position, charts, and navigation data are all speaking the same language,
Okay.
preventing any miscommunications.
So it's all about ensuring that everything aligns perfectly,
yes,
like those gears in a well-oiled machine.
you got it.
Yeah.
And finally,
Okay.
this manual touches on the future of PBN, those cutting-edge concepts like advanced RNP or ARNP.
ARNP sounds futuristic. What's that all about?
Imagine curved approaches and departures,
Okay.
allowing aircraft to navigate more efficiently in challenging environments,
Okay.
like those mountainous regions.
So it's like taking those winding mountain roads instead of the straight highways in the sky.
Exactly.
Yeah.
It's all about maximizing flexibility and efficiency.
Right.
ARNP is paving the way for a future of air travel.
Yeah.
It's not just more precise, but potentially more environmentally friendly.
It's like PBN is constantly evolving,
It is.
pushing those boundaries of what's possible in the air.
It really is.
Yeah.
And that brings us to a thought-provoking question this manual leaves us with.
Yeah.
With this increasing reliance on GNSS, what backup systems and pilot skills become even more critical in this new era of PBN? It's
Yeah.
something every pilot needs to consider.
Because as amazing as technology is,
It is.
it's not foolproof.
Exactly. We've talked about RAIM as that safety net.
Right.
But as pilots, we always need to be prepared for those what-if scenarios.
Right.
Those times when our systems might not be there to bail us out.
So it's about having a deep understanding of those traditional navigation techniques.
Yes.
Being able to read a chart,
Yes.
use those radio navaids,
Yeah.
and really know those backup instruments inside and out.
Precisely.
Hmm.
And maybe even more importantly,
Yeah.
it's about cultivating that critical thinking mindset, being able to assess a situation,
Right.
make those split-second decisions,
Right.
and adapt when things don't go according to plan. Those are the skills that set apart a good pilot from a great one.
It's like having those wilderness survival skills.
Exactly.
Even if you have the latest GPS and satellite phone,
Right.
knowing how to navigate with a compass and build a fire could save your life.
I love that analogy. It's about being well-rounded,
Yeah.
having that balance of technological proficiency and those core skills that have always been the bedrock of aviation.
This deep dive has been incredible. We didn't just scratch the surface of PBN.
No.
We really got into the nuts and bolts, explored those real-world scenarios.
We did.
And I think it's safe to say that PBN is more than just a passing fad.
It
It's reshaping the way we think about instrument flying.
absolutely is.
Yeah.
And as pilots, embracing these advancements
Right.
while respecting those fundamental skills, that's the key to a future of safe and efficient flight.
So to all you pilots out there, keep learning, keep challenging yourselves, and keep exploring the exciting world of PBN. Until next time, fly safe.